All right, welcome to class, everyone. It's good to see you. Down a few people, I'm not sure why, but today we're going to start learning about C++, and so this should be fun, I think. Let me share my screen here. And share. Okay, there we go. All right, so as we can see here, of course, today is the 17th. The whole rest of the time, we're going to be looking at C++. The blackjack assignment is due on Thursday, and so you should be working on that. If you have questions, please come. This REPL A1, actually should be A1 through A8. I see there's a typo there. That is due not today, even though it says so, but I gave you an extra day because I delayed in publishing it, so I apologize about that. After today, you're going to start doing C++ replets. I'm going to show you a little bit about that after I'm done with today's today's presentation. And so it's the same way, only it's a different REPL course. And so I sent everybody invitations to that new REPL course. And so you need to accept that invitation. And if you didn't get it or you're having trouble with it, you need to contact me. Same thing for the book. The book is documented up here. Also, I sent everybody an email message. It's Python, C++ for Python programmers. What you need to do is go into your Runestone account that you go to for how to think like a computer scientist. You need to go in there and you need to add a course, and then you put in this course into the little box that says which course it is, and then you'll have two textbooks that you can access, and it works just the same way as the old textbook, and it's free just like the other one. So it's all a pretty good deal, and I think it's a good textbook. And so you will be working on these C++ REPLs, and I think I've only written them up to around 30, so I still have a few more to write, but hopefully I'll get those done. But all of them are published, I think, up to 30. Okay. Any questions at this point? So the slides for today are on the web page. And again, it's C++ for Python programmers. So the idea here is we're going to be learning a new language. But it turns out that learning a new programming language, if you already know a programming language, is way easier than, say, learning a new speaking language if you already know it. Like, as you know, learning, if you've never spoke Spanish, learning Spanish is hard, right? It's easier for some people than others, but and learning languages that are really different, like going from English to, say, Russian, is even harder. Well, in programming, there's so much more similarities that it's actually not that hard to move from one language to another language. And it's actually really good to know more than one language, to have more than one under your belt. So now, why are we learning C++? Why not Java or JavaScript or one of a multitude of other languages? Turns out C++ is a very popular, powerful language with lots of features because it's a high-level language that allows low-level features. It's for this reason, by the way, a lot of system code, like operating systems and powerful applications are written in C++. A lot of the web is powered by C++. But it also turns out that you can write C++ code without knowing all the different complexities of it. You can just use pieces of it and still find it useful. C++ actually is kind of the mother of all modern languages, okay? It influenced languages such as C#, Java, newer versions of C. Certainly it has had some influence on Python. In fact, Python is mostly written in C++. C++ is an industrial strength programming language and is very often used today for large systems by large groups of people, right? People build large infrastructure, both in terms of applications on the web, but like, for example, if you're writing code for aviation, for airplanes, you know, for air traffic control, for all sorts of stuff, big systems run on C++. The internet, the core, the guts of the internet are all written in C and C++. The code that's running on the little router in your house, or that's running in the big firewalls at Kenyon, is all C++. None of that is in Python, none of it. C++ is particularly good at interacting directly with the hardware. This is one of the reasons why they do things like routers and switches and telephone services. All this stuff has to talk to hardware, and C++ is actually good at that. Python is terrible at that. And this also makes C++ very fast. In general, C++ is much faster than languages like Python, and this is the reason why Python modules are actually written in C++. C++ was the first widely used object-oriented programming in the world. There were object-oriented languages before it, but until C++ came along, they were not the major ones. As I said last time in class, I believe I said it to this class, there was a version of C called Objective-C that came along before C++ that Apple created when they made the Macintosh, which had a profound impact too, but it never had as wide of use because it was a proprietary language only used by Apple. And frankly, it was a lot harder to learn. iPhones used to be programmed in Objective-C, but now they're programmed in a language called Swift, although there's still lots of C deep down in the phone. Because C++ is fast, it is currently the language of choice for computer graphics, high performance modeling, virtual reality, and 2 and 3D game engines. And C++ is still one of the top listed in job advertisements. In fact, we go here. Here's a website that shows this literally month by month is updated with the popularity of languages. You can read through this, but it's based on lots of metrics. They do a composite of job advertisements, what things like Google, Bing, and Yahoo show, and you can see actually C is the most popular language, which is the predecessor to C++. And if you know how to program in C++, you know how to program in C. And then second currently is Python. Python has been going up dramatically. Java is very popular. JavaScript is very popular. C# is Microsoft's version of C++, is probably the best way to say it. So here's actually these things. We notice up here, this green is Java. Java used to dominate, but it's going down. And this second thing is C. C's kind of dipped, but has been coming back up. Right here, the black is Python. It's been going up and down, but recently coming up. So there are, these are all important languages, and they're good languages to know. Let's look at our first C++ program, and by the way, there's a link here we'll go to in a second, and we'll run it. But, well, actually, maybe I'll go there now. So if I go there, here's a little program, I run it, and notice I'm in C. I'm not in Python now. I'm using the C version of Python, of REPL. I hit start, and it says hello world. Well, let's look at this code. I'm not sure why this code is so badly formatted, actually. So let me fix that. Okay, so let's go back over here and look at the code. So what do we have here? Well, let's see. This include IO stream is what we need to include to do input and output. Now, this is just like the import in Python. Okay. The brackets, these greater than or less than brackets, mean that it's a system library. It means we're bringing it in from the system. We can also bring in our own modules, which we'll learn how to do, but this means it's a system one. If we use quotes, it's a local library. Again, we'll see examples of that, not today, but soon. So notice the program says int main. All programs must have a main. This is a function. It turns out that in C, everything has to be in a function. You can't not have code in a function. And so the main function is the function that you always have to have. And when you run the program, it runs the main function. Now it looks a little different, right? We don't see a def here. We see a function name and we see parentheses after it, which we're kind of used to. And then we see these braces or curly brackets. So it turns out that in C++, instead of indenting doesn't mean anything. We can indent, we should indent, but we don't have to indent. What we do instead is every time we have a block of code that goes together, we put these brackets around it. So that means this code goes together the same way indenting means this code goes together in Python. So that's a kind of a big difference there. The main function is normally supposed to return a 0, which means everything is okay. In C++, all lines that are executable end in a semicolon. You have to put a semicolon in. The semicolon means this is the end of a line. And in fact, you can have a line that's more than one line long, and there's only going to be one semicolon to indicate, no matter how many lines long it is, here's where it ends. This is in a sense, a semicolon is what tells where one line ends and the next begins, not spacing, not tabs, not lines. The only thing that separates lines, commands, is semicolons. So we'll get used to that. It'll take a while. Again, in C++ is free formatting. You could do all of your code. You could do all this code on the same line. And C++ would be like, I don't care. You could put line breaks in the middle of things, as long as you don't put them in really weird places, like the middle of a variable
name. I just submitted with my French test.
Hello? Somebody have a question? So, however, it's important that you indent similar to like you do in Python, because if you don't, you're going to become confused. So notice that we indented these lines, not because we have to, but because we want the code to look nice. So we indent anyway to make it look nice. Okay, now, one major difference between Python and C++ is something called compilation. It turns out that Python uses an interpreter. Interpreter looks at the source code as it runs, decides what it's supposed to do, and does it, right? We see this here at the bottom. We have a source code, we have a program called Python that runs the code by looking at it and doing it. This is similar to an interpreter, a language interpreter, right? The way a language interpreter works is if I want to give a talk to a group of let's say, I'm in Tokyo and I want to give a talk to some Japanese computer scientists, and they don't say they don't know English. Well, I might have an interpreter stand next to me and I say something, then she says something, right? I say something else, then she says something else. And so the translator takes line by line and takes what I'm saying. I mean, not the translator, the interpreter, it is a translator, but is interpreting, taking what I'm saying and turning it into another language on the fly as I'm saying it. Now, the other thing, now what C++ does is something different. It uses something called compilation. And what it does is, beforehand, before I run the program, it converts it into the low-level machine code of the language. And then when I want to run it, it just runs the machine code. Now, it turns out this is why C++ is faster, because once you compile it, it doesn't have to reinterpret the code over and over again. It's just real quick. And again, to put this in perspective, if I want to read a novel, say I want to read Dostoevsky's Crime and Punishment, right? It would be a lot more cumbersome if I had to have an interpreter sitting with me, reading it line by line for me, right? Instead, what do we have? We have a translator who translates it once, and then lots and lots of people can read the same translation, and it's a lot quicker to read it. So this is some of the trade-offs between Python and C++. So in C++, we have comments just like we do in Python, but notice the difference here. We don't use pound signs. In fact, pound sign means something else that we're going to see. We see a pound sign here. That doesn't mean a comment. Pound sign is what we do before the include. Basically, a pound sign is something called a directive that says, I want you to do something for me. It's not a comment. Where do we see comments? Well, if we want to have comments, especially comments that span multiple lines, when I do a /* that means I'm starting a comment. And I can go as long as I want, lines and lines, pages and pages. And then when I do the */, that's the end of the comment. Now this actually is pretty useful. It's kind of like the quote, 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 and then some stuff and quote, quote, quote in Python, right? It's a way of having a block of comments without having to put a pound sign on every line. And, right? Now the other way is more like the Python pound sign, and that's the //. / means just this line is a comment. And again, I'm not going to go there, but well, maybe I will. Let's see. Here's some code here. Here it is. Here's a simple code program. We run it, and it says, hello world. Notice I have this. We have this mystery thing that I'm not going to talk about yet, but for right now, we're always going to put this at the top of every program, okay? It turns out we don't have to have that, but if we don't have that, we have to put other stuff in that makes the programming a little more cumbersome. Then I have a comment here. I have some comments here, and I have a comment here.
Do you always have to indent when using the multi-line comment?
Never. You never have to indent anywhere in C++.
Okay.
C++ does not care about indenting, but you should indent, but you don't have to. Now, just like Python, C++ has a variety of simple data types, and then it also has more complex object type, class/object type data types. The simple data types, there's 5 of them. There's bool, which is a true or false. There's char, which is a character in single quotes, has to be single quotes, not double quotes. There's a float, and that's a typical, number with a decimal point. Now a double is a float that has twice the precision. Okay, they both work exactly the same, but if you want a more precise number, you use double. It has twice as many bits in memory as the float does. In terms of precision, the difference is a float has about 6 digits of accuracy, whereas a double has like 20 digits or something. I don't remember the last numbers, but a double is significantly more, allows you significantly more precision if you need it. And then there's an int, which is an integer. Now let's see how we use these. Well, it turns out in C++, you always must define variables before you use them, and you must give them a type when you define them. So here we're saying, I want to make an integer. In fact, I'm making 2 integers. You can always put a list. I'm making an integer x and an integer y. Here I'm making a float I'm calling speed. I'm making a double called av. I'm making 2 booleans, one called done and one called false. And here I'm making a character called C. Now notice again, semicolons at the end of every line. Now down here, I'm using those variables. And I use them just like I do in Python. Much of the same rules are true. Now, notice that in Python, true and false use a capital T and F. In C++, they don't use a capital. Oh, you can also define the type. You can also give a value, you can also give a variable a value when you assign them, much as we see here. So this is sort of a more terse version of this code. Here I'm defining them, and here I'm using them. Here I'm defining them and what we call initializing them, or setting them up with their first value. Then I can go on and continue to use them. Now here's the important thing to remember. C++ is strongly typed. Python is weakly typed. What does this mean? Strongly typed means is once you declare a variable to be a certain type, it's that type forever. You can't change the type of a variable. In Python, anytime you want, you can assign a variable any type of value you want, and that variable becomes that new value type, right? And you've seen that before. Can't do that in C++.
So, Professor Scan,
Yes.
is it more accurate to say that we declare variables? Do we define variables or declare variables?
That's a good question.
Yeah,
yeah, well, tell me what you think.
I think we declare variables. It's similar to, especially when we do functions in C++,
Right, you declare.
We declare a function and then we define it. For variables, I think we declare them.
Right, yeah, you're right. That's probably a better word here. These are
is it a good idea to use false as a variable name for the Boolean variable?
That's not a variable name. That's the actual word false.
No, in the declaration on the left side.
Well,
on the top.
Are you asking if this will work?
No, on the left.
Yeah.
So we have 2 Boolean variables, done and false.
Right. Oh, I meant for that. That's a typo. I meant for that to be fast. That's just a typo.
Okay.
I literally made this slide this morning. So I thank you for helping me correct it. Thank you. Yeah, you can't do that. That's a good point. Just as in Python, in C++, variables there's certain words that are called keywords, and you can't use those for variable names. So true and false can't be the name of a variable. So yeah. Okay. So now again, we're going to try all this hands-on, but what I'm doing here today is I'm giving us an opportunity to sort of kind of journey through the differences before you sit down and actually do it, okay? So let's look at this comparison here. Conditionals, right? In Python, we can say F and a condition, colon, and then we can have a group of statements. In C++, we say F. We have to put the condition always in parentheses. And then we put the statements inside of these braces. The statements do not have to be indented, but we should indent them, okay? And so let's look at an example of this code. Here's some code here. Now here I have, it all looks very much like it does before, but notice it only it says I have an integer x equals 50, an integer y equals 100, and I say if x is less than y, print hello world. Sure enough. Now if I change this to 25, it doesn't print hello world, right? Because it looks very much like Python. So now we also have, like Python, the possibility of an else. It looks very similar. Condition has to be in parentheses. And then what we do is we do the begin and ending bracket for the first block, we do the else, and then we do the begin and end brackets for the second. Let's look at that. So here's some code here. So here we have 50, x is 50 and y is 10. And then we say if x is less than y, again, it's in parentheses. Then inside of these brackets, we say x is the largest, otherwise we say y is the largest. We run it, sure enough. I mean, is the least, sorry, 10 is the least, right? So if I make this be 100, $50 is the least, right? So we see how this works. Now again, if I fork this because I don't want to mess this up, but C++ doesn't care about lines, right? I can do stuff like this, and it'll still run. In fact, I can even do this, make it look awful. Still runs. I can even do this. It's a crappy looking program, but it still runs. Okay.
Professor,
Yes.
what is the end part at the very end of the line?
This right here.
No, not that one. Like, if you
You
go
mean
back
the
to
code we were looking at?
no, yeah, after, for example, console output y is the least, and then it shows end L or end 1, but what is that end L or something?
Oh, right. Okay. So we're going to get to that. This whole thing is how we do I/O. I'm going to talk about that a little later. This is like a print statement. Okay. So what we're saying is cout, and then we're outputting this stuff. Again, we'll talk about this in a second, but it turns out that this is the operator that says send this value to cout. Anything you send to cout appears on the screen. This gets sent to cout. End L stands for end line. It's equivalent to, in fact, it's totally equivalent to a /n, just like in Python. In fact, I could do this. I could replace this with /new line, and it would do exactly the same thing.
Oh.
Okay, but it's a prettier way of doing an end line. So good question. Thank you. Okay. So we'll talk in a bit about that. Now, there's an LF in Python, but there's not an LF in C++, but what there is an else F, which is virtually the same. So here we have in Python, grade equals 85 if grade is less than 60, print F. LF, grade is less than 70, D. LF, grade is less than 80, C. And then B, and then A, right? We've seen code like that. We can do the same thing in C++. And I have to have my extra stuff, but then I say grade is equal to 85. It's an integer. If grade is less than 60, I'm C-outing an F and a new line. Else F, grade is less than 70. So I use the else F instead of LF. And now Python has loops, and they look a lot like C++ loops. And they have the same differences as we had with the if statement, right? So we have a while, condition, and then statements. Here we have a while, condition in parentheses, and statements. Let's look at an example. Here we have a Python program that we set the counter to 1, and we say counter, while counter is less than or equal to 5, print hello, and then we increment a counter. This is going to print hello 5 times. Here, we set a variable to 1, just like we did over here. We say while it's less than or equal to 5, we print hello, and we increment our counter. Now, wait a second. Oh, I lost where I was at there. Okay, yeah. I think I'm going the wrong way. Okay, so now I've totally lost where I'm at here. Yeah. Okay, so I got it. I'm sorry. I think there's where I'm at. Okay, so there's the counter. So what about for loops? Well, it turns out that for loops are a little different and in some ways simpler. Now, of course, Python has a lot of different ways of doing for loops, but I'm only going to show this one as a comparison to C++, right? We can say for x in range n, and then it does some stuff. In C++, the way we would do that, we would say for, have to have parentheses, and then we give 3 things. We give the starting condition, which we say we start out with an integer equal to x. We could have any integer here. We could actually have any type here. And then we say, this is the, how do I know if I'm done? So it's kind of like a while. We're saying as long as x is less than n, do this. And this looks kind of funny, but this is what we do at the end of every loop. Now C++, in fact, this is why C is called C++. It's a pun because we had C and we went to C++. C++ is the next C. And what a plus plus does in C++ is it adds 1 to a number. Now that doesn't work in Python. So this says start out at 0, set x, as long as x is less than n, do this, and then when we're done doing this, go ahead and add 1 to x and do it again and do it again. So here's an example. Here's a typical Python. It'll print hello 5 times. This actually will print hello 10 times. And whoops. And let's try it out. So I'm going to grab this code, go over to, let's just pop this code into here. Let me fork this first so I don't mess anything up. So let's see what happens. There it is. It did hello. Now it turns out I can actually output the I every time. And we see 0 through 9, right? Because it starts at 0. As long as it's less than 9, the I is being incremented every time. So that's kind of cool. So again, I realize I'm going through this fast. I'm wanting to give you a sort of a flyover of C++. So don't worry if it's like, this is too much. I don't think I can program. I don't expect you to, right? Now, here, let's look at this code here. This is a complete program with a for loop. What do we have? Again, the first part of the for, before the semicolon, initializes a loop counter. It's done once before we start. The next thing is the condition that we check every time. We stop whenever that's false. The third is how we go to the next step. Now, it wouldn't have to be I++. We could say I equals I plus 2, or I is equal to I minus 1, right? We could do anything we want, but this advances us to the next thing. So we could start with, for example, I equals 10, and we could say, well, I is greater than 0, and we could actually say I minus minus, or I equals I minus 1, and we could go from 10 down to 0. So we can make this do a lot of different stuff. So here's a little loop here. Squares the numbers in range 5, okay? In other words, it's going to square 0, square 1, square 2, square 3, square 4. Now, for some reason, this thing is really wonky when I hit the scroll thing. So let's try this code. We'll take it and go over here. We'll run it. See, 0, 1, 4, 6, 9, 16, right? We squared 0, we squared 1, we squared 2, squared 3, squared 4, right? I could make this go higher by making it, 10. And there we go higher. I could make it only do evens by saying I plus equal 2. It's only squaring even numbers, right? And again, I could go a lot higher. Let's see what happens. We'll try to blow it up. There we go. Squared all the even numbers less than 100. If I change this to less than or equal to, we should go all the way up to 10,000. All right. So, if he's asked about this earlier, now we're going to talk about it. C++ input, output. We have something in C++ called standard out. And that just means it's going to basically what historically has been called the terminal or the console, right? Which is the screen you see and the keyboard in front of you. So cout is an object. It's actually an object, just like an object in Python, that provides for output to the screen. It's called standard output. The greater than greater is an operator, just like plus is an operator or minus is an operator. This is an operator that is called the insertion operator, and it's used to send data to the cout object. Thus, the cout is an object, and, well, actually, I see an error here. This should be that. Insertion means basically insert this output in the object, which then causes it to be displayed on the screen. So if I say cout insertion operator output sentence, that prints output sentence on the screen. I can cout 120. I can cout the value of X, right? And it turns out I can do a whole line of things like we saw earlier. So I could say cout X, and then I could do the insertion operator Y, then do the insertion operator, and then C. I can output as many things as I want on a line. Now, cin is the converse, and again, I see I have a typo here, so I'm going to fix this. The cin operator goes this way, and the cin reads from the keyboard. and it converts automatically whatever you type in into the type of variable that you're trying to put it in, if possible. So that's kind of nice, right? Python doesn't do that. Python, it always comes in as a string. C++ brings it in and converts it into the type that you're trying to put it into. This operator is called the extraction operator. So if I say int age and I do cin greater than age, basically the terminal is going to, the program's going to stop and it's going to wait for you to type something in. Now, if you type in a number, it's going to go into age. If you type in a string, it's going to give you an error. Here, we're asking for a float, and there's a missing semicolon, so this is an erroneous program. And here, we're doing something cool. We're asking for two things to come in. So here's an example piece of code, and let me actually put this in REPL and try it out. So here's some code, and notice we include IOStream. Now I'm actually including string, and I technically don't need to because most newer versions of C++ automatically include string, but here I'm using strings. I'm going to talk about that in a second, but a string is a class, and that's what I have to use if I want to have something more than just a single character. So here I have a string. It's a new data type called myString, and I see out what's your name. I see something new here, get line, and here I say hello, whatever I typed in. I see out what's your favorite team. I get the team and I print it out. Let's see how this works. So what's your name? Jim Scon. Hello, what's your favorite team? The Lords, of course. I like Lords too, right? So that's it. Now, earlier I showed this doesn't matter. Earlier I showed a different way of doing it. Get line is one way of getting things in. Let's see what the difference is between that and this kind of CN. I'm using the same string over. So let's see what's different. Okay, so what's your name? If I type in Jim and I type in Lords, this also works, right? I'm outputting something and I'm bringing something in, but there's a difference. Watch this. What's your name? Jim Scon. Hello, Jim. What's your favorite team? I like Scon too. What happened there? Well, it turns out CN does something called tokenizing. And what it does is whatever comes in, it breaks it up. It splits it, just like Python split. It splits it based on white space. And so it only takes in one thing at a time. So when I typed in Jim Scon, I never even got a chance to type in anything else because Jim went into here the first time and then Scon was still waiting. And that went into here when I did the second CN. So CN only ever does one thing at a time. Now I could do this a little different and kind of solve this problem because I could do CN into A and then into B. And then I could do this, CN into C. And I could do A, B, and here I do C. And I can see that this will work. Let's try this. Jim, Scon, and Kenyon. That works, but what if I do this? Jim, What? It says, I got to have something else. It will not go on until I type in something else. So now I type in scon. Hello, Jim Scon. What's your favorite team? And again, I have to be careful because what if I type in Jim Scon, Jim Paul Scon, my full name? Hello, Jim Paul, right? Because those are the first two things I typed in. I also like scon too because there was something in there, right? So if you want to read a whole line like input in Python, you've got to use the get line. If you want to read in just individual chunks or tokens, you use cin. All right. So that's our Flash introduction to C++. Now let's try it. I'd like everybody here to try it. So what I want you to do is I want you to go to REPL and let's create a new. So what we do is we go in here and we want to get C++. Notice there's a whole bunch of languages here, but we're going to get C++ and we're going to create something. So go ahead and see if you can get in there. And notice what it gives you by default is it gives you a hello world program just to get you started. Now, this shows something different. Notice it says std : and cout. Basically, anytime you have a class, you have to tell where that class is at. And this is saying it's in the standard area, right? And so what happens is if you're going to use anything with classes, which includes cout and it also includes strings. For example, if I make a string here, let's say I want to do cin, cin into a. Well, I better have an a, so let's make a string called a. It's not going to work. You know, all these errors. Why? Because all of these things have to have standard in front of them. STD stands for standard. Before it'll work. Now it's waiting for something to be input, so I put in Jim, and it says hello world. In fact, what I could do is hello world. Right? So now, Jim, hello world, Jim, right? So it's kind of annoying that I have to put all those STDs in front of everything. The way to get around that is you do what we've been doing all along here, is we use this using namespace. STD, semicolon. That, the program would still work, but that just says anywhere you need it, put STD in. And we're only ever going to use STD in this class. And so that makes our code easier. Okay? So all of our programs are always going to, almost always our programs are going to start with these two lines. So have you guys all got C++ working? So let's try something here. Write a program that asks the user for their name and greets them with their name. So how would we do that? Well, how would we ask a user for their name? Well, we want to print something out, right? So we could say cout, and then we're going to send to cout something like, what is your name? Right? And then I could say cin into name. Now, of course, that's not going to work because in C++, I have to define something before I use it. So I'm saying name is a string. Then I can say cout, you know, nice to meet you. Oops. I did this the wrong way. Nice to meet you. Name and line. All right, so go ahead and try that. Go ahead and put all that in. See if you can get that working. What's your name? You know, Jim. It says nice to meet you, Jim. Now, of course, as we saw before, if I type in Jim Scon, let's see what happens. Nice to meet you, Jim. See, and only puts in one thing. The other things basically are waiting there if I do another CN, but since I don't do another CN, they just eventually get thrown away when the program ends. So how do we fix that? Well, we can fix that using the get line we saw earlier. An alternative is to say get line, and then I say get line into CN, and then I give the variable name I want it to go in. This is a special function. It expects as its first parameter a place to get the input from, and as its second parameter where to put it. Put my semicolon at the end, and now if I type in Jim, it works. But if I type in Jim Scon, and it works. And if I type in, you know, James Tiberius Landau, you know, I'm just making up names here. Randolph. Pippin. Scon. It works, right? Because I can put as much as I want in there. You guys able to get this working? Yeah, it's kind of fun. It's a whole new way to look at things. So if we go back to here, what if we want to modify the previous program so that only users Alice and Bob are greeted with their names? In other words, if they type in Alice or Bob, it'll say hi. If they hi Bob or hi Alice, if it's anybody else, it'll just say hi. Huh. So possibly now we want to go back and just do the CN into name because I want a single name. And I'm going to need to have some sort of condition, right? So I could say F. Now I can do just like in Python, I can say name equal Bob, right? I said Bob or Alice. Now, here's where things get interesting. And again, in your reading, you're going to see this. The operators are a little different in C++. I don't do an and here. If I do and, because what I want to do is something like and name, not and, or. I want to do something like or and, or name equal to quote Alice. Right? That's kind of the sort of thing I want to do. I'll tab this in to make it look nice. And what I could do is we could put an else in there and just say something like else cout sup Okay, now if I run this, it's not going to work. Actually, I'm surprised it's even compiled. Let's see what happens. Jim sup. That's strange. Do you have any comment on this, Noah?
Yeah, that's strange. I'm surprised too. So let's try the
I mean,
usual
I'm
thing
like,
and
what's
that
going on
works.
here? I've never seen this work before.
Yeah, that's weird.
Maybe this is a newer version of C++, and maybe they added OR as a possibility. Interesting.
Yeah,
Because normally you do ORs as two vertical bars, which is the thing over the return, the shift the thing over the return. What is your name? Alice.
yeah, that's news.
Well, never saw that before. I typed it in. I thought, why is it getting a red underline? Well, I thought, well, certainly it won't run. So I'm glad it's not just me, right? Well, did I miss something? Apparently so. I'm gonna have to Google that and see what's going on with that, because I've been programming in C since, well before any of you guys were born, and I've never seen this. You learned something new, apparently.
Yeah.
You'll have to try that with the C compiler you use. I think this is C14. I'm not sure. There is a C++ 17 also, but I don't think we're using C++ 17. But maybe we are.
Professor, we
Yeah,
are.
I think this is
Oh, we
17.
are using 17. Ah, you're right. So this must be something they added in 17.
Yeah, it
Very
must be.
interesting. Okay, well. So how would we write a program that asks for the number n and prints the sum of the numbers 1 to n? Now, Well, let's try that. We can kind of keep the same code. Clearly, we're going to need an integer n, right? And then I could I could send a prompt out. I can say, enter an integer, please. Right? And then I could use a while statement, or I could use a for statement, right? So let's try it with well, first I better get my number in, Cn into n. So what I want to do is count from 1 to n. So I probably better let's make another integer called total, or maybe I'll call it sum. And now I need to count from 1 to sum, right? So what I could do is I could do this, int I equals 1, and then I could say while I is less than or equal to 10. Notice the editor automatically indents for us, which is kind of nice. And when I put in a begin bracket, it automatically puts in an end bracket. And by the way, when I click on a bracket, it shows the matching bracket. I can say sum plus equals I. And then I better say I. Now I can just say I plus plus. That makes I go to the next one. So let's see if this works. Oh, it's not going to be much fun if I don't print out the answer, right? So cout. So I see out the total, sum, the word total, sum, and end line. Let's run this. Enter an integer, please. 10. Oh, wait. That's right. If I'm going to, I wanted to go to a number n. So let's stop this again. Enter number 10. Well, that's not right. So this is an important thing to notice. Anybody know what happened here? Let's try it again. Gee.
The I++ shouldn't be there, but within the while statement.
Well, the I++ is in the while statement. I'm going to do something here. Just put in a diagnostic here. Notice sum has a value in it. This is an important thing to understand about C++, and it's different than Python. When you make a new variable, it doesn't put anything in it. So we need to start it at 0. We need to initialize our variables before we use them. Now this one we don't need to initialize because we're going to be putting something into it. But now when we do it, it should work. Now, there we go. 10. 55, that looks right. 100, 50, 50. 1 million. Okay. It works, right? So we did it with a while statement. Now, I could do this with a for statement. And let's try that. For, now I don't need to do an integer I here because I'm going to actually do it in here. For integer I equals 1, that's my starting place. As long as I is less than n, or less than or equal to n, that's what we had. And then I do my I plus plus. Oops, got an extra one of these in there. And now I can do my sum plus equals I. Now notice I don't have to do the I plus plus down in here because I'm doing it in here. Let's try it. 55. 10. So it works, right? So which way is better? You know, the for is a little more succinct in this case. But just like in Python, the for is for definite loops, i.e. loops we know how many times they're going to execute. And the while is typically for indefinite loops, loops that we don't know how many times it needs to run because we figure that out as we go.
So let's
Yeah.
So let's not initialize sum and print the value right after to see the garbage that it contains, right? Uninitialized.
Take this, you want me to take this out, yeah?
Yeah, and then let's print it before we add anything to it
All right.
to show that there is garbage in it.
See out sum okay.
Yeah.
Now, interesting. What it's defaulting to is the maximum integer, the maximum 32-bit integer. Don't know why. Signed integer, maximum signed 2-bit integer. I mean 2-byte integer. Weird. I don't know why it's falling on that, but I could also do.
But it is probably system dependent, right? You don't expect.
Right. It's not always going to be the same. In fact, look, I did n here. Let me put the n The end came out as 0. The sum came out as 32,700. Now this time it was 766. In fact, see if it's there. Now it's 765. Now it's 766, right? So it's unpredictable, right? This is something you have to be careful of. Now notice,
Uninitialized variables, yeah, it is a
Yeah.
major problem for beginner programmers.
right? So we have 15 minutes left. What I'm going to do now, so that's to get you started. Now, I have some simple problems for you to do, REPL problems 1 through 7. Let me go into one of those, and let's just do the first one and show you. They're just like you go into your C++ Fall 2020. Go into the assignments and let's pick one. There's a ton of them in here, so let's pick the first one. Sum of 3 numbers, okay? You go in there. Some of you guys have already done it. You guys are amazing, okay? So this, I just give a little bit of starter code, and it says, write a program that takes 3 numbers and prints their sum. Every number is given on a separate line. It actually doesn't have to be on a separate line, but so let's see, how would we do that? Well, I obviously need 3 variables, so let's make 3 variables. And then it turns out this is pretty easy because I can C in X, C in Y, C and Z all on the same line, and then I can C out their sum. So these are very simple programs, and we can run this. And let's see, 2, 3, 3, 4, 5, got a 12. Now I can, oh, you know what I did? I just changed the master. No, I didn't do a student preview, so okay, I better undo this. So anyway, I should have gone into student preview mode. Otherwise, I was actually changing the live version so that it would already be solved for you. And then I can print out X plus Y plus Z. All right, so we can run it. Let's make sure it works. Yep, now I can submit it. And sure enough, it passes all the tests. So it's just like the Python thing, right? And so this is, you know, your way to get in there with hands-on, do the reading, try to do these. Come to office hours if you have a problem. Like I said, I actually have 31 of them out there now, and they're due on different days. Okay, so and again, I'll be adding maybe 10 more. We'll see. And these are all newly written, by the way. So if something seems funny and it's not working right, let me know. I've written solutions for all of them and tested them, but unlike the other ones you've been doing are pretty tried and true. These are brand new. This is a brand new thing. So there could be problems. And so don't feel bad. Don't think it's necessarily your fault if things don't work. Okay, last thing I want to talk about today is I want to go a little bit more over the blackjack. Okay, so by the way, just in case you want to know how blackjack works, I made a Philander Chase's blackjack program, and you can kind of get used to how it plays, right? You got a 12, the dealer has a 9 plus a hidden card, and you say hit, and you go over. So you start over. Your hand is 7, you say a hit, you get a 7, so it goes to 14, you do a hit, you went over. You got a 15, let's say, I'm scared, I'm gonna stay, and the dealer hits, and the dealer went over. The dealer drew a total of 5 cards, and the dealer busted, and so you win, right? And so then here down at the bottom, we have our wins, draws, where wins, draws, and losses. And Philander Chase looks on with appreciation for the amazing playing I did. So, so that's just so that you can see how the program works. You're supposed to write that. Now, I've given you a lot. And by the way, here's a full run of exactly what the program should look like. So it already has some of this stuff in there. It starts out by, it deals the cards, and it shows one card for the dealer. By the way, I put in this little thing you can figure out how to do if you want, that actually shows the suit. Shows one card, the 8 of spades, your hand, queen of clubs, 8 of clubs, your tally is 18, hit or stand. It's a draw, you both have 18. I stood, and so it was a draw. So the dealer draws an 8 and something else. Oh, this shows the final, oh, then it shows the dealer's final hand, so you know what they actually had. Then it shows the win, losses, and draws, asks if you want to go again, deals the new cards. The dealer gets a 6 of hearts. We get these 2 clubs. Your tally is 17. So again, you say stand. The dealer draws a card. It's a draw. We both have 17, so we had draw 2 times in a row. And so it kind of goes on like that. So you should look through this and see how the gameplay goes. Now, in the blackjack start, what we have is, again, I have a main class, I have a main program that's a partially complete game, just like tic-tac-toe and just like hangman. You have to finish it. But then I have a card class that's pretty much done, right? The card class has these class variables, and the card class has a constructor for the cards, and the card class has the ability of returning the value of a card. So I give you that class. So then I have a class for deck, and what the deck does is when you create a deck, this part's already done. It creates a list of all the cards in the deck using a list comprehension. It doesn't shuffle it, which is actually really easy. This is a diagnostic routine that I should actually write that. You shouldn't have this, use this in your final program. That shows a list of all of the cards. And then here, you normally don't look through the deck, right? And then here's a function that's already written that draws by popping a deck off. So the only thing you have to finish here is the shuffle. Then in the hand, basically, when you create a hand, it has an owner and it's an empty list of cards. Here's how we add a card to the list. Here's how we could return the first card in their hand. Here you have to finish writing to get a list of cards in the hand. And then here's a partially created algorithm which counts through the cards and figures out how much they're worth. And again, it has to take into account the aces, because the aces are worth either 1 or 11, depending on your score. So on the main line proceeds basically down here. I have a little bit of code that basically has a bogus option, and the number only keeps track of the number of wins. You're going to have to modify that to keep track of the wins, losses, and draws. And it says as long as they don't input a cue, play the game. And here I'm saying if they win, increment the win. Again, you're going to have to modify that so that it does wins, draws, and losses. When we call the game, what the game does is it calls new game, which basically creates a new game by creating a deck, shuffling it, drawing 2 cards into the dealer hand, drawing 2 cards into the player hand, and then it returns the deck, the dealer hand, and the player hand down into here, which we call A deck, dealer, and player. Then I set false, stand equals to false, and then I say, as long as nobody's gone, as long as everybody's below 21, and the player hasn't decided to stand, it shows the dealer's card, it shows the player's hand, which doesn't work because this function has to be written by you. And then it says, if you're not standing, it asks the player, what do they want to do? Do they want to get another card or do they want to stand? And if they want to hit, it draws another deck and adds it to the list. Else, if they say they want to stand, we set stand is equal to true, which is going to break us out of that loop. Now, here's the dealer's strategy. The dealer's strategy is the dealer is always going to draw a card as long as they're less than 17 or equal to 17. Now, you can change that strategy if you want. I don't care. You can make whatever strategy you want. Dealer draw. And so this has to be finished. There's some missing code in here. And then this shows one type of win. And one type of win is if you get a 21 and you only have 2 cards. In other words, if you get 21 on your first draw, that's the best possible thing. That's called a blackjack. There's lots of other ways you can win, and there's lots of other ways you're going to lose. You're going to have a bunch of if then else's here, which are going to check all the conditions and to see who wins, who draws, who loses. And then you either want to return a status of a win, lose, or draw back to here so that you can count those things. So that's basically, I'm giving you a lot here, but it's giving you an opportunity to mess around with classes. Okay. Any questions on that? So let me just show you this in the last couple of minutes. Going back to the syllabus just to see where we're going. We're going to rewrite 3 programs we've already written. So this is going to make it a little easier. Okay, so after a week from today, you're going to take the payroll program that you wrote at the beginning of the class, and you're going to rewrite it in C++. Okay, so it's exactly the same program, only you're writing it in C++. And I show you in this program, I don't have time to talk about it right now, but I show you how you can do formatting. Formatting of output so you don't get long digits, long decimal point numbers is different, and I show you how to do that. The next program you're going to do, which is due December 3, is you're going to write the Hangman program in C++. And then the final one, you're going to write the Blackjack program. Now, it turns out that the Blackjack program, I give you, just like I do in C++, I give you a starting point, and you finish it, okay? So you're going to use classes to do, in C++, to do Blackjack. You're going to use lists, which are called vectors, to do the Hangman program. So that's pretty much the rest of the class. Okay, I will see you guys later. Take care.
Thank you, Professor.
Thank you.
Thank you.
Professor? Professor?
Yes.
I was completing my French exam, so that's the reason I was late. And I was running